So let's talk a little bit about what we know about varying directly and inversely. So when something varies, sorry, let me get my pen. When something varies directly, right, we know that there is a relationship, let's say between peaches and apples, of a constant between the two. And it's almost like using a scale factor, right? So the number of peaches is equal to some number times the number of apples. So when you have so many apples, that constant is going to tell you how many peaches there are. So for instance, if our constant was 3 and I had 4 apples, then I would have 12 peaches. That's the direct variation. The direct variation says that as apples increases or decreases, then the number of peaches increases and decreases proportionately, and that allows us to use a proportion statement as well. So we could also write this problem and get the same answer by saying P1 over P2, which is the number of peaches in the beginning, over the number of peaches in the end, is set equal to the number of apples in the beginning over the number of apples in the end. And that allows us, because of this constant relationship, that allows us to write it like this and solve it and get the same answer, because there's direct correlation between the beginning numbers and the ending numbers. All right, with varies inversely, however, we think about the word inversely and what it means. It means to invert, or the inverse of something. So we know the inverse operation of multiplication is division. So it makes sense that the formula for varies inversely would be a fraction. It's going to be the inverse operation of the varies directly statement because it's the inverse. It's the inverted operation. And likewise, the proportion formula is going to be P1 over P2, the beginning number of peaches over the ending number of peaches, and it's going to be related to the inverted fraction. So the number of apples at the end over the number of apples at the beginning. So you could see that inversion going on in that second fraction of your proportionality statement. And if you solve it this way or this way, you are going to get the same answer regardless. So let's talk about combining those things. It's a operation or a relationship called varies jointly. And when we have a varies jointly statement, we're going to see how that works. And for instance, we are told that peaches vary inversely as apples and raisins. So there's a joint relationship between the apples and raisins, and they vary jointly as the peaches. So we could put them together, the apples and raisins, on the bottom here. We could also put them in the proportionality statement. We could say the peaches at the beginning over the peaches at the end are inverted to the apples at the end and the raisins at the end over the apples at the beginning and the raisins at the beginning. Now we can also mix that relationship up, and we could actually combine where we have direct variation and an inverse variation in the same problem. So for instance, if I were to say that the number of peaches, all right, sorry, I didn't mean to do that. The number of peaches varies directly as the number of apples, but inversely as the number of raisins. We could write that just like that. It's all about the wording in the problem and what that wording means. And if we're told that it varies jointly, we have to determine whether or not those are a direct variation, a joint direct variation, or an inverse joint variation, or if one's inverse and one is direct. So let's look at the first problem here. You're going to want to write these down, because this could also, we could put these together and we could say P is equal to, I think I put K over, let's say R over A, which would be the same thing as P1 over P2 is equal to A2 R1, because R is directly, because it's on the numerator, and this would be A1 R2. So if they have different variations, one is directly and one is inversely, that's what you would have, something like that. All right, so let me pause this and write 96.1 so that we can see what we have as our first example, and we can start to solve some of these and see what we're doing. All right, in 96.1, the number of girls varied inversely as the number of boys. All right, so let's write that down. The number of girls, I gotta get my pen back. The number of girls varied inversely as the number of boys and directly as the number of teachers. All right, so we see how that works. We can also write a proportionality statement with the same information. So the number of girls, G1 over G2, is equal to, they varied inversely as the number of boys. So we invert the boys. So we have B2 and B1. So those are inverted to the girls, but directly as the number of teachers. So the teachers are going to be directly related to the girls. So the same outcome or the same event, all right, has to match the girls. So that's how we would write the formula, and this is how we would write the proportionality statement to solve this. And you can use either one of these to solve based on your understanding. When there were 50 girls, there were 20 teachers and 10 boys. All right, so that's the first go round. So when there were 50 girls, there were 20 teachers, remember we're on the first occurrence, and 10 boys. Okay? So for this problem, this is as far as we can go right now. We have to solve this first and come up with our constant or our scale factor. So fairly easily, we multiply both of these by 10. This times 10 is 500. This times 10 just eliminates the denominator, so K times 20. We divide both sides by 20, and we get that we have a constant of 25. All right, so then how many boys were there when there were 10 girls? So 10 is our G2 number, and 100 teachers. That's our T2 number, so times 100. And we need to find out the final number for the boys. So in this instance, we're going to rewrite this formula and put in the new information. So there's 10 girls, and we have a constant of 25 and 100 teachers. So 10 equals 2,500 . What am I leaving out? Oh, divided by B. Divided by B. So we multiply both sides by B, and we get 10B is equal to 2,500. And then we divide both sides by 10. We find that the number of boys is 250 whenever this condition is present. So if we're over here solving it proportionally, notice right away that we're not using as many steps, right? So I am going to, first of all, divide this to 5 just to get rid of the fraction. And then I am going to, it's going to be 20 times b over 2 over 1,000. All right, I'm going to multiply both sides by 1,000, so 5,000 is equal to 20 times b2. And when I divide both sides by 20, I find that 250 50 is equal to the number of boys when these conditions are present. It's the same answer. We just got there a little bit faster. That's why I do tend to prefer proportionality statements, but understanding where it comes from is very important as well. That's why we started with the formula, so we can see that inversion process and why we need to swap these events in our proportion statement. Okay, so that is how you would solve for this problem using the formula or the proportionality statement. So let's move on to 96.2 and look at something a little bit different. All right, 96.2. Strawberries vary jointly as plums and tomatoes. So notice the word jointly and as. Plums and tomatoes. So this implies a relationship of a direct joint variation. So we are going to say that strawberries is equal to the constant times the plums and the tomatoes. That is what is implied by this statement here. So if 500 strawberries went with 4 plums and 25 tomatoes, how many plums would go with 40 strawberries and 2 tomatoes? So we can write a proportionality statement based off of this right here, and that's going to be pretty straightforward. It is the direct relationship, so we have S1, S2 for the first event of strawberries, and the second event of strawberries is equal to the first event of plums and tomatoes over the second event of plums and tomatoes. So that's pretty straightforward as well with that direct variation. So now we just sub in our information. So if 500 strawberries went with 4 plums and 25 tomatoes, 500 is equal to K times 100. Divide both sides by 100. We get that 5 is the constant. Now we put that back into our formula. How many plums would go with 40 strawberries? And our constant is 5. And we don't know how many plums, but then that's times 2 tomatoes. So 40 is equal to 10 times the number of plums. Divide both sides by 10. That would be 4 plums. Okay, so now let's work it on this side. So if we have 500 strawberries in the first event and 40 strawberries in the second event, the first event of plums is 4. The second event of plums, we don't know. That's P2. We don't have a clue what P2 is. T1 is 25 tomatoes. T2 is 2 tomatoes. So now we just do the math. We have 500 over 40 equals 100 over 2 times P2. All right, so 50 divided by 4. That's going to be a number that I'm not going to solve just yet. What I'm going to do is I'm going to multiply 2 times P2 times both sides so that I can eliminate this denominator here. So 2 times P2, you don't always have to do the math exactly in the order you think it ought to happen. So we have 2 times 500, that's going to be 1,000, right? P2 over 40 equals 100. All right, and if I divide 1,000 by 40, then that is going to be 100 divided by 4. That's going to be 25. Is that right? Yes, 25 P2 is equal to 100. So I divide both sides by 25. And I get that P2 is equal to 4 plums, which is the same number I got over here. All right, and actually this time around, this was a little bit easier to solve than this one because the numbers were so big. So it just depends on, the way that you see it and the way that makes sense to you. I will say this, I still like the proportionality statement because I didn't have to go back and rewrite a formula and sub it in. It all was one problem from the beginning to the end. I just had to think about my steps, but we still got the same answer at the end for both ways, so that means we did it right. Yay! So both times we found that we would have 4 plums as our result when we had 40 strawberries and 2 tomatoes because they varied jointly together, which was a direct variation. And we were able to write both of those formulas and proportionality statements accurately. And that's all we have for lesson 96. I'll see you guys in lesson 97.